Welcome back, class. Thanks for tuning in. Hope that everyone's safe and healthy and that you're doing well. We're going to start right in with our part 3 of this week, week 7, and we're going to go over the Google form. So tune in, and we're going to jump right in. Let's go to the iPad here. So what you're looking at here, you're looking at the ideas of what we're talking about this week. We're still doing proper scientific notation, but we're going to be doing adding, subtracting, multiplying, and dividing them using actual decimal forms. So that's what we've been kind of working on, and I'm hoping that this makes sense, and we'll kind of go through it. So I got 11 problems picked out that sent in the Google form, and hopefully these will make sense to you as we go. If we need to, we'll jump right to the calculator and whatnot, and we'll kind of see how that's going. Okay, so let's jump right in and let's see how this works. Okay, so the first problem that was in the Google form, we are adding 2 together. Now remember, when you add 2, what you have to make sure of is that these powers of 10 need to be the same. Now the good news is they are. So it's like a label, it's like an X. Those are the same, so we can add the 2 things together. Now what we add is the leading coefficients. We add these 2 numbers together, and that gives us our final answer. So now the final answer will have a power of 10 to the 5th. Now when we add these 2 together, we're just adding the 5.4 and the 4.4. Now most of you can just do that in your head. That's great. That's kind of what we want. Now, if we need to change anything, that's because the power of 10, maybe it's off. But in my case, I'm going to just add straight down. You just line up decimals. You add straight down, that's an 8. Add straight down, that's a 9. The decimal comes straight down. So my answer will be 9.8 times 10 to the 5th. That's your first one. Let's jump right to the next one. Okay, second problem. Now, in this one, we just have to make sure we are subtracting. So we have to make sure the powers of 10 are the same, which they are. So the label would stay the same. So it would be 10 times 10 to the power of 3, or 10 cubed. Now, when you subtract, you just take the leading coefficients, which are 12.2 and 10.1, and we subtract them. So when we subtract straight down, the 2 minus 1 is 1, the 2 minus 0 is 2, and 1 minus 1 would go away. That would make 0. So my answer is 2.1 times 10 to the 3rd. So now, in real numbers, what this would be, it would be this. It would be 2,100. Now, how I know that is because it's positive power of 3, right? So we move the decimal back 3 spots, and this is what the number would be. Now again, how you can do this, you could write out what each of these numbers are that you see in front of you, the 12.2 times 10 to the 3rd, just figure out what that number is. It's 12,200 minus the 10,100, and you get your 2110, or 2,100. So let's jump right to our third problem here. Alright, so what we have here is we're going to try to multiply these together. Now, with multiplying, it's not like adding and subtracting. You can just multiply any 2 numbers together. The powers of 10 will get thrown in the back. So 10 to the 4th and 10 squared. Those get thrown in the back. We're going to add those together later because it's like a variable, right? When you multiply things, the variables just get dumped in the back. And what you do is you actually just multiply the 3.3 times the 1.2. You're just multiplying those. Now I'm going to jump to the calculator here. We're going to multiply these 2 numbers together. Now if you want to do it by hand, fine and dandy, you could do that. I think I did, but let's transition right into it. Okay, so what we have here is we have 3.3. So 3.3, we're going to take that times 1.2. And what we're getting is 3.96. That is this number, 3.96. That number goes here. Now we're almost finished. This is almost the final number. What we need to do now is we need to jump right in here, and finish out the power of 10 in the back. So the 10 to the 4th, 10 to the 2nd, this will make 10 to the 6th power, because there's times 10, times 10, times 10, right? You're just putting all those 10s in the back, and there's 6 of them total, and then the 3.96 will stay there. And this would be my final answer on this problem. Now, why this makes sense? Times 10 to the 6th is a really big number, right? We move the decimal back 6 spots, so this would be, maybe the millions or whatnot. And so the idea is that this number is big. Well, it makes sense because you're multiplying 2 really big numbers together, right? You're taking 3.3 times 10 to the 4th, which is, 33,000 if you move the decimal back 4 spots. And you're taking that times, if I move the decimal back 2 spots, 120. So if you multiply those together, yeah, it makes sense if we're in, the millions range. So this number, 3.96, makes sense to me. Let's jump right into the next one. I think we're on the 4th problem now. We're subtracting, again. So if we're subtracting, we just have to make sure the powers of 10 are the same. It's not like multiplying. We don't care about multiplying. But on subtracting, we just make sure these powers of 10 are the same. They are. So my answer will be times 10 to the 4th. And what we're going to do is we're going to take the 5.4 and subtract the 1.3. Now, I shouldn't need a calculator here. We can just do it by hand. 4 minus 3 is 1. The 5 minus 1 is 4. And so my answer is 4.1 times 10 to the 4th. Again, if you just write these numbers out and what their original numbers are, you can subtract them the same, but this is the proper scientific notation. Okay, next one, same thing again. We're subtracting 2. We just need to make sure the powers of 10 are the same. They are. We don't need to change these two numbers. So it'll be times 10 to the 3rd in the back. We're going to subtract the 13.4, and we're going to subtract the 5.4. Now again, notice I lined up the decimals. That's how you subtract decimals. The 4s will cancel out to make 0. I can get rid of that here in a minute. 13 minus 5, what is that, 8? If I did that correctly. And so it's 8.0, which you can just write as the number 8. It's the same thing, and there's your answer. So it's 8 times 10 to the 3rd. Should be the answer. So if I move that back 3 spots, the decimal currently is right behind the 8. That'd be what, 8,000? Kind of makes sense. If I move that back 3 spots, it's 13,400 minus 5,400. So yeah, makes sense, 8,000. Okay. All right. Let's go to number, what are we on? Problem number 6 now. All right. So now we're dividing. So in dividing, it doesn't really matter if you have the same powers of 10. So we talked about that in the video that we did on Monday. So times 10 to the 5th, and we're going to divide by 2 times 10 to the 3rd. Now, the 10s in the back, you just subtract top minus bottom. That's how you technically divide. It's called a cancellation method. So if I subtract those, I'll have times 10 to the 2nd, because 5 minus the bottom, 5 minus the 3. And then the leading numbers, the 12.5 and the 2, you just divide those. So 12.5 is in the house, the 2 is on the outside. 2 can go into 12 6 times. That makes a remainder of 0. Bring this down, that's a 5. 2 can go into 5, what, twice without going over? That's a 4. Subtract, you get 1. Bring down the next digit. You can always put zeros in the back. 2 can go into 10 5 times, and that makes a perfect remainder of 0, so that's what we want. So a perfect remainder of 0 with no other numbers that we need. We can move this decimal straight up. So it's 6.25. Now again, if you're not trusting that, go into your calculator. I can switch the calculator and take 12.5 and divide by 2. Some people probably can just do that in their head, 12.5 divided by 2. But there you go. Moving on to the next one. What are we on? Problem number 7 now. We're going to be adding. So again, with adding, we have to make sure the powers of 10 are the same. That's different than multiplying and dividing, remember. So 10s to the 5th, we're going to leave those alone. Those are good. We're going to leave those. We're going to be adding the 6.7 and the 5.4. So if we add these together, the 7 plus 4 is 11, carry the 1. 6 plus 5 is 11 plus 1 is 12, so it's 12.1. And that would be my final answer there. So again, you can double check if you want to change these back to original like decimal form and add them together. Okay, let's go to the next one. I think we're on problem number 8 out of the 11 we have. Alright, so what do we have? We have, we're multiplying. So multiplying, we don't care about the power of 10s. We'll just throw those in the back. So multiplying, we can just throw all the variables in the back, the like terms, the times 10s in the back. We're going to take the 6.4 and take it times the 5.1. Now, if you want to do this by hand, you can do the column method here. In fact, I'll just do that for you. If you want to do it by lattice method or scaffolding, however you want to call it, from elementary days, you can do that. But 1 times 4 is 4, 1 times 6 is 6. Move on to the next row, get rid of that. 5 times 4 is 20, carry the 2. 5 times 6 is 30, plus the 2 is 32. And then you add these two numbers together, so it's 3,264. And then I have to move the decimal over since it has decimals. There's 2 decimal places there. There's 1 here and 1 there. So I move it over 2 spots, so it's 32.64. And then obviously the powers of 10, there'd be 10 to the 6th power. Because you add 10 to the 3rd and 10 to the 3rd. So this is technically the scientific notation. It's not proper because the decimal isn't behind the first number, but this is technically the same number. If you want to make this, 1 more space, so it's proper scientific notation, this would be 10 to the 7th power. So, because I moved it over 1 more spot, so you have to add 1 more to the power. But there you go. They're the same number. Let's move on to the next one here. What do we have? Problem number 9, I think here. So we're dividing. So again, the powers of 10 don't matter. We're taking the 24.6 times 10 to the 5th, and we're dividing by 6 times 10 to the 3rd. Again, just like before, we subtract the powers of 10, top minus bottom, so we're going to get times 10 to the 2nd. That's great. 24.6, we're going to divide by the 6. Now, 6 can go into 24 4 times. It's perfect. Bring down the next number. 6 can go into 6 once perfectly, and that makes me a remainder of 0. Move the decimal straight up, so it's 4.1 times 10 to the second. So again, maybe it's kind of refreshing your skills from elementary days of how to divide. Maybe you did division differently than I have. This is column method is called long division with a house. Let's go to problem number 10 here. Okay, so we're adding again, so we have to have the powers of 10 the same. So the powers of 10 are 10 to the third or 10 cubed. So we'll leave those. Those are the same. So that's perfect. We're going to add the 5.6 and the 4.5. We're going to add these two together. So if we add, we're getting 11. That makes what? Perfect 10. Bring down the decimal, so it's 10.1. Now, if you want to move the decimal over, it's technically 1.01 times 10 to the fourth, because I added one more decimal place, but they're the same number, it didn't matter. And the last problem, we're adding again. So we have times 10 to the third, so 10 cubed. So I'll leave that alone, because when you add, those stay the same. And I'm adding 3.4 and 5.4. So if we add these together, that's an 8, and that's an 8, so 8.8 times 10 to the third. So pretty straightforward. Again, for all those who are actively participating in some of these activities, I know we only have a couple weeks left. We have, I think, 2 weeks left. The next couple videos will be different. They're going to be different material, but this is something that you can apply to any form of math. It doesn't matter if it's geometry or pre-calc or calculus. Making numbers smaller so you can actually do the math in your head or on paper. It's kind of a skill that a lot of people are losing. They're kind of just relying on calculators and not really common sense thinking about numbers. It can definitely help you on like an IOTA-based skill or ACT or anything of that form. I think it's kind of an essential skill. But again, thank you for all those who are participating. Again, I'm hoping that you're healthy and safe, that you're taking care of your families. That's kind of first priority, but I hope to see you guys real soon. Take care.